Hello everybody and welcome to the Carolan Cymru revision sessions. The session this evening will focus on GCSE physics and will be presented by Dr Nettle from e-sgol Gymraeg Yslovela. The session will last around 5 minutes where I will run through the relevant content. If you have any questions during the session, please use the Q&A section and we'll do our best to answer you. You'll see that there should be a hyperlink in the Q&A section. If you're happy to leave your name and email address, we would love to keep in touch with you so that we can send you information about future events. You can click the link at any time during the session. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carolan Cymru tab. Thank you. So to begin this evening's session, I've gone back and looked at all the resources on the e-sgol website, and what I've seen is that there's a lot of variety of content there. So I thought the one thing that might be missing is actually looking at preparing for your summer exams. So what I've done is looked at everything you're going to be doing through the Carolan Cymru website, and I can see you've ticked off a lot of the content. However, what would be useful over the next few weeks is to look at how we can best prepare for the summer exams. In the second week, we'll hopefully go through some QER, the questions with extended reasoning, and try and prioritise how to approach those questions. And then in the third and fourth week, I plan to answer step by step 2 full past papers from the recent group of past papers, just so that you can see not just a focus on one content, but focusing on that exam technique, seeing as there's so much resources available on the Carolan Cymru website. So today now, preparing for exams is going to be the focus. And to prepare for exams, we need to rewind a little bit and look at the most useful aspects of proper preparation for physics. What we need to do is look at the timetable, essentially look at what time you can place in front of you from now to your exam to best put you in that right mindset ready for the exam. We then look at the notes, so how you may have notes now and how you can adapt those notes and edit those notes to make them a better revision resource for you. Look at different strategies. So over the next 45 minutes, we can have a look at a few strategies and discuss what makes a strategy for revision good or bad, especially essential for physics. The fourth thing we're going to look at is unique to this exam year. We're going to look at the advanced information for students. That is information that's been provided by the exam board, WJEC, that is available to all learners to help them understand which questions to focus on and which content will have the greatest number of marks. And the final thing we're going to look at is knowledge organisation. That is condensing a lot of that information down to make it better for you to read through, look over and prepare for the exam. So preparation for exams, what we're going to look at is that revision timetable, organising our notes, different strategies, working on recall and past paper questions. Those are probably some of the 5 key things that best sets you up for success in your exams. If we look at the top, the revision timetable might be the first thing you want to think about because that's when you've got the most time is now. Organising your notes is often the second thing because now you're coming to the end of being taught the content. Now you're at the perfect time to really start looking at your notes to see if they are acceptable and useful to revise, or were they useful to learn the content and not necessarily the best resource to revise. Now is your time to start exploring a few strategies and find a few suitable ones. I've put down work on recall because quite often there's a great deal of marks awarded for the ability to recall definitions, recall how to do certain steps. And the best thing, which is kept for last, is that past paper questions. You need to go from notes to past paper questions in a short amount of time because that exam is approaching. So that revision timetable, what makes a good timetable for physics or just for the entire exams? Well, first thing you want to do is maybe look at how much time you can actually place to revise for. You might find at the minute you're still in school, so ideally, are you the type of person that gets up early, or are you the type of person that could use their school lunch period to find a suitable 30-minute stop where you can start to look over work? If not, after school is where we often find a lot of learners placing their revision time. Once you finish school, you then open your whole day. It's available for all your subjects. What you want to do is rank the topics. Very important, because you know you have strengths and weaknesses, especially within physics. You often find one or two topics you feel you're really confident and you can answer quite to a good standard, and you might not need to put as much time into those as other topics. So you definitely need to rank those topics and start looking at which ones you can address. The third thing for a good revision timetable is to set achievable revision session slots. There's no good saying you'll spend all of Saturday morning revising and studying up on physics, because what you often find is 3 hours slot of a morning is too much time to stay focused. It doesn't work for everyone. A lot of learners like to have 30 minutes up to an hour with important breaks in between. Those breaks are just as important because it allows you to reset, to get yourself in a calm frame of mind, ready for the next topic. So please think about what's achievable, how long of a revision slot works for you. That way then you can have a goal within each session. And that could be going over a topic so that you can answer at least 1 to 5 questions, depending on how close to the exam we're getting. Answering 1 question within each session to a high standard. And it's also important then, looking at your timetable, is ensuring you have plenty of rest, having goals within each session within the week, but also be flexible. There's no good having too much revision or too little revision. You need to understand you have school, you have other priorities, but exams should be in there, and you should be flexible and understand that you might not be in the correct frame of mind one day, or you might need to take a little break. If you find your revising is not getting anywhere that evening, you could even take a little break and come back 30 minutes later after having a drink or a snack. So now that you've got a nice revision timetable, what we want to do is streamline you so that you're ready for your exam. And a good learner would have kept their notes from throughout their learning experience. And you might find you might have a large amount of notes for physics because you might have a lot of past paper questions embedded in your notes. You might have long explanations to really help you learn it the first time. But now that you've learned it, you might not need to rely on those large notes that you have, and you might want to condense them down. So organising notes and summarising is a very good strategy to actually start your revision process. Starting it earlier is one of the best things to do, because leaving it late means that you're not going to have the time to practice your exam technique. So, for example, a good thing to do is take an entire topic and can you condense it down to a single page? If you can condense it down to a single page, do you tick off the important information needed? So once you've summarised your notes, you can keep these notes out, and then in your little exam question sessions, keep it out to go through the question. And as you answer more questions, you'll find you need to rely on your summary less and less. And before you know it, you wouldn't need your little summary sheets because you can answer them from being able to recall that information in your mind. If summarising notes is too daunting or you've left it too late, you need to be aware there are plenty of summary notes available online. You can search for them, revision sheets online. I've put a few at the end of this PowerPoint, different styles so that you can look through it. Are they to your style? But nothing beats making your own summary note that's suitable for you. So a handmade one helps you because you might put more detail to the area that you didn't fully understand to help you fine-tune your understanding. You might put less detail to the region of that work which you fully understood and you didn't need any of that help. Good, so now we've looked at understanding our timeline before the exam. You now have an idea of you might want to condense your notes so you've got something very useful that's not a large book. We need to look at different strategies. They come in two techniques or two categories. We have passive techniques, which doesn't require much input from the learner, doesn't require much of that brain power. And as a result, by not using much of the brain power to apply this technique, you're not going to get much of the brain activation. Therefore, you're not going to really be getting the most out of it. So these are the ones that worry me when I ask some of my learners, how are they going to revise, when they say they're just going to read their notes or they're just going to highlight through their notes. Then it worries me because that way they're not looking or exploring different strategies. So reading your notes might not get you all the way there. Copying or typing out your notes word for word, again, is not the same thing as condensing your notes and putting notes into your own words that are suitable for you. So passive techniques are something you should focus on at a minimum. What you should be looking at are active techniques. So active techniques are obviously ones where you have to put a lot more input into. So you start them earlier and you will reap the rewards as you go through and hopefully succeed at your exam. So for example, the first active technique, which you can start at any time, is take your notes and create some flashcards out of those notes, or look at some old questions. For example, definitions. You might have something like state the equation, linking distance, speed and time, and in doing so give the appropriate units. This is a good prompt. You've created this flashcard, so you've already identified this as an equation that's very important. And secondly, you should have the answer on the back that you can practice daily, or you can put it in your weekly revision timetable, a flashcard session. That way then you can quiz yourself, or if you're in a study group, you can work as a pair or as three of you and go through the flashcards and make a game of it. Enjoy that revision time you have. A second active technique are rhymes, stories and mnemonics. You might think, how do these fit into physics? Well, one of the nicest ways that I enjoy teaching the order of the planets is with the mnemonic, my very easy method just speeds up naming planets. This is useful because what it does, it puts the order of the planets in our solar system in order closest to the sun to furthest away, and that is something you're expected to learn for your exam because it can come up in a question. So something like mnemonics are unique to you, or even through looking in your revision resources, you might already have learned a few of them that might help you in the exam. One active technique that many enjoy is sticky notes. You can use them in multiple ways. You can use them like flashcards and set up a number of questions where you will then have to go through each sticky note and find the answer as you go. You can use them to put definitions, so the definition is always available for that revision session. So if you're going through some past papers, you might want the definitions, and at the end of the session you realised you've had to use them, and as time has gone on you can slowly remove the sticky notes because you're relying on them less and less. Finally, one of the most powerful and important ones could be exam questions. Nothing beats looking at questions in the style that they will be asking you in this summer. So by sitting down and answering all of the previous past papers with your revision aids, with your knowledge organisers, with your summary notes, and then checking your answers, working through them and seeing that you needed your revision notes the first time round, repeating the same process, answering the same questions again, but this time finding you rely on your revision notes less and less. So by the end, you can sit past papers without any revision aid, and that means you are ready to sit the exam this summer. And the final thing that a lot of learners should be familiar with are mind maps that focus on summarising your notes. So now that we've got this far, we now know some strategies. We understand the importance of organising your notes to make them useful and not make them too daunting to look at. We've looked at that revision timetable, so organising your time. We can think about the exam. So it's important to understand what you should have been taught and what you should have learned for your exam. And there are two options. You may be doing physics, the single award or triple science, where you do the physics, chemistry and biology separate, which accumulates 3 GCSEs, or you could be sitting the double award physics or double award science, which includes physics, chemistry and biology, which awards 2 GCSEs. So what I put the link to the two of them, and these links will take you to the correct website and will show you the specification. The specification is essentially the checklist or the tick list of the information you need to know for the entire course. So if you go to those websites, what you'll see is for physics, on the left-hand side, you'll see a list of content for the Year 11, the Unit 2 exam. On the right, you'll see the double award physics side, which is the Year 11 Unit 6 paper. And we can see there's a big overlap with the topics. You'd expect to see a few more in the full physics GCSE, but I have highlighted or put a red box around the ones that overlap between double awards. That way, in tonight's session, we can focus on these, which are identical across the two. So what we see is distance, speed and acceleration, Newton's laws, work and energy, stars and planets, types of radiation and half-life. So with this specification in mind, we can think towards the summer exam. And a nice thing this year is they have released advanced information to enable you to better prepare for the exam. What this means is they've released information on what is included in the exam so that you can maybe focus more of your revision time on that topic in question. That way, timetabling is very important. Getting your time organised, understanding that your notes are suitable, and have a good strategy in mind so we can make the most of this advanced information. So the advanced information can be found on those WJEC websites. And for physics, you will find the advanced information will look like this, and there'll be a few pages going through what each unit and what each exam and how it's been modified. And for the double award, it will look like this because obviously it includes the biology, chemistry of year 10 and 11. So for year 11 this year, we can look at, first of all, that unit 2 exam of year 11, and we can look at what the advanced information so you can better prepare this year. So remember now, you make a little checklist of which ones to focus on more, come back to the e-sgol website, go into the Caroline Cymru section and make the most of those lessons to help you in your revision. And if we look at the foundation tier, so any of you sitting foundation tier of the physics course, or you might refer to it as the triple award because this would be the separate physics, chemistry and biology. Well, what we see is in the advanced information, they have ranked Newton's laws and work and energy as going to be the most marks, the largest questions, the ones you really would want to focus on. So again, if you're making a tick list, those 2 units are of great weighting, so you really want to focus them. Third, distance, speed and acceleration, and what you see there is the first 3 units from your unit 2 course account for the largest 3 marks in the exam. So again, think about how you're going to focus on it, and that might be something you might want to consider. If it's a strength of yours, doesn't mean you shouldn't minimize your revision for it. You might want to reconsider putting more time there. At the other end, you might find that the least amount of marks will be found for topics such as nuclear decay and energy, half-life, and stars and planets. So that way you now know how to plan your revision. It also, in the advanced information, it includes the practical work. That means the question, work and energy, will be weighted with a lot of marks, and the question will have elements of practical work. So you need to understand what the prac actually is for work and energy. Similarly, types of radiation and further motion concepts are going to have elements of practical work in the question. So again, you might want to think, go back, were you in class when you went through the practical sides of these? Because it's important that you can visualize what that prac was, what the results you would typically see, so that you're best prepared to explain on the day. If we look at the higher tier physics, what we find is it does change very little on the top. The largest number of marks are awarded again for Newton's laws, work and energy, and distance, speed and acceleration. And again, we find that the practical work for work and energy will be in part of that work and energy question. Doesn't mean that the whole question might be focused on it, but it means there will be elements of it. Again, types of radiation, just like in foundation, also includes the practical side of it. However, this time, at the bottom end, the lower end of the mark, we could find the universe and further motion concepts. So it's something you might want to weigh in when you're looking at planning your revision timetable. Next, if we look at the double award science, or Unit 6, if you're familiar with that, what you find is the Unit 6, or the double award physics exam, the foundation tier. So again, pay attention if you're doing foundation or higher, you can see the largest number of marks will be awarded for distance, speed and acceleration. And the following three, which is half-life, Newton's laws and work and energy, will have elements of practical work in those questions. So looking at this, of the 6 topics, 3 of them focus on practical work or will have elements of practical work in the question. That should mean half of the exam will come from the practical side of understanding. So you really need to understand and identify what the expected practical was for these topics. If we look at the higher tier, what we can see is work and energy is right at the top, which is different to the foundation tier. So work and energy will have the greatest weighting. Newton's laws is second. And in the middle, we have the types of radiation and half-life, where half-life will have an aspect of practical work. And the least and lowest number of marks will be found for stars and planets. So again, use this to help tailor your revision experience ready for the exams. So it's important that you understand which exam you're doing, which tier you sit in, so that you can make the most of the 4 different advanced informations depending on your exam. So in the session today, we have covered a few different things to help prepare you for the summer exams. We've looked at the timetable, how best to create a timetable that's suitable for you. We've looked at understanding the importance of notes and not just relying on the notes, but using those notes to condense them and then using those summaries to help you. We've looked at a few different strategies. We've gone from passive and understanding the active strategies is what you should be aiming for. We've now had a quick look at advanced information, which is very, very useful for this summer because they have released it for this year only, and it would hopefully will benefit you if you make the most of it. And the final thing we can look at now is knowledge organization, this idea of reducing your notes so they are suitable for your revision. So for each topic that we have just studied or looked at ready for your exam in that advanced information, we can zoom in a bit more and have a look at what really you should have learnt during each individual topic. So in the advanced information, they did say that distance, speed and acceleration was the question with the most marks in the foundation tier double award. So this might be very important to look at for you guys. However, if you sit in the higher tier, you might find this ranked 5th. So you might put this as a lower priority. if you're sitting higher tier physics, the triple award or the physics single award, however you have learnt it in school, this is ranked 3rd in terms of that advanced information, and it's the same in foundation. So it's very important to make sure you understand each point in this unit. So with your notes and this checklist, you can go through it and tick off or make a flashcard for each element. Do you understand what speed, velocity and acceleration mean? Can you use that terminology and possibly explain each one? I hope you have had time to explore speed time and distance time graphs, and it's very important to not confuse the two. So always, if you are revising these, I would definitely like to see notes where you would separate them or list them, not necessarily side by side, but make it clear one axis has distance and the other has speed. So thinking about how you condense your notes, it can be confusing if you don't label things clearly. The third thing that they expect to see that you have learned so that you can apply it are the equations for speed, which is obviously distance over time, or acceleration, which is that change in velocity. And again, make a note that there is a difference between velocity and speed. D, which is the 4th point, an understanding of what velocity time graphs are in order to determine acceleration. So everybody, foundation and higher tier, would be expected to understand what a velocity time graph is and how you can determine acceleration from it. In bold, the bold that is there for anyone sitting higher tier because it enables them to understand that is an additional aspect that could come up in the higher tier paper. How can you use a velocity time graph to calculate distance travelled? Because in the exam, they might ask you to calculate the distance from a velocity time graph, but it's your responsibility to remember it is determined by the area under the graph. The final 2 bullet points, E and F, are application ones. So E is applying some of this knowledge to better understanding vehicles, how they stop, and terms such as thinking distance, braking distance, and total or overall stop and distance. You need to have an understanding of the factors that affect these distances. So point E is a good point to turn into flashcards because you can have one for the factors and you can have a list of a number of factors. You can focus on the factors of thinking and then braking and then pull them all together. And the final bullet point is F, which is being able to apply yourself to answering questions on the physics of motion together using data and opinions to discuss traffic control arising from the above. So looking at speed limits and the use of speed belts or even speed control measures you might find on the road. So this is the type of information you should have learnt. And a good thing now is if you did plan your revision wisely, you might want to go back through this PowerPoint, click on that link that takes you to the WJEC site, because there are a lot of resources to help you get started. So from all of that information, those A through to F, what we can see here is WJEC has created an example of a knowledge organizer that might help you in your revision. And we can see that idea of motion, speed, distance and time. And we can see we have speed over here, the understanding of what they are, speed time or distance time and velocity time graphs. What we can see is they've dedicated a large amount of this page to demonstrating the typical shape on the graph. Can you see that they are identified distance for this column? So it's useful for you to focus on distance, and you can then keep checking if you have a question, an exam question that you're working on, and this is out and it's asking you to sketch the motion of a train or a car, and you understand it's stationary through each of these stages. You can just use the shape of each line and grow your graph into a full distance or velocity time graph. What we can do then is we can look at a typical velocity time graph because they have allocated again a large amount of this revision page to velocity time graph. Is that an important factor? It might be, because it might help you understand labeling and looking at describing each section of a velocity time graph. Again, what they've done on the knowledge organizer is they put down here that the distance travelled can be calculated by calculating the area under the line of the graph. So what that means is calculating this area that I am sectioning off now. But in your exam, it might not necessarily say calculate the distance by calculating the area. The question could just say calculate the distance, and you'll be expected to remember in order to succeed at that, you have to calculate the area under. So be aware, you need to understand that distance is found by calculating the area. And on the bottom, maybe quarter of this page here now, the quarter of this page is dedicated to this idea of stopping distances, factors that affect stopping distances. Quite often, there's a question that might ask for 1 or 2 factors from each one. So maybe focus on 1 or 2 from each one, or learn all 4. But again, weigh them out, look at it, and be careful with the idea that speed does affect thinking and braking. But if the question says other than speed, what other factors are there, then there will be no marks for the word speed. So please make sure you take the time to read the question, because it may come up other than one of the factors, just so you don't fall into that little pitfall of recalling word for word. If we think now, what other topics are weighted quite heavily this year? Well, Newton's laws is weighted as the highest ranked in the higher tier physics paper this year, and the content for that is quite large. It's ranked 2nd for the higher tier in the double award, so it might be quite useful to quickly go through it. It is ticked as being a question that includes practical work in the foundation tier paper, so it is important that we tick off and understand each one of these elements. So Newton's laws has A through to G, and what we see here, the first one is understanding the concept of inertia, and that mass is an expression of inertia. So that's quite a short, basic one that I hope you picked up quite quickly. The second one is Newton's first law of motion, but then as a higher tier, be able to state it. So again, thinking of post-it notes, you want to be able to recall and state that law of motion. Please think of post-it notes or flashcards, so you can have one side, Newton's first law, other side, the actual answer that you are expected to learn. C, an understanding of unbalanced forces and how that results in a change in motion. When the force or the resultant force is non-zero, an acceleration will occur. And logically, leading on from that, you'll have Newton's second law. So you're expected to know that, and again, higher tier, you're looking at being able to state it. So you're thinking flashcards, or you're thinking post-it notes. A few different ways of stating it. Some like to learn the equation and be able to use the equation to form the sentence, such as the resultant force is directly proportional to mass, and the resultant force is directly proportional to acceleration. That is one way. That way, then, you're using the equation to state it. Now that you understand the non-zero force results in an acceleration, the fifth thing you're expected to know is this understanding of weight and mass, and how mass is a measure of the matter of the object, how much matter it has. However, weight is the effect of the gravitational field strength on that mass. And this will come in the form of weight is equal to the mass times the gravitational field strength, and the gravitational field strength on Earth is 10. So it might not necessarily put that in the question, but 10 newtons per kilogram is the value of the gravitational field strength on Earth. F is then looking at these forces and being able to understand these forces of an object falling through the air and how an object will not continue to accelerate in air because of air resistance and this idea of objects reaching a terminal speed. So this directly links to the practical work, which is crucial for anyone sitting physics this year, foundation tier, double award, because it is an element of the question. So this will definitely be something they will want to review, look through, and see what they did to investigate the terminal speed of a falling object. The final point is Newton's third law of motion, and from that, again, think in bold, are you able to state it? So we can have a quick look at what a knowledge organizer from WJEC might look like. So you might want to use it, or ideally you can use this to help you create one that is more suitable for you. So when we look through a checklist, we've got something such as, does it cover Newton's first law and state it well enough for you to make the most of it? So we can see right here, we have Newton's first law. Straight away, we have the statement for it, which is that Newton's first law states an object will remain at rest or at a constant velocity unless it is acted upon by an external resultant force. So each word there is important. You can't just say at rest without or at a constant velocity. They go together as a pair when you are stating the first law. They also have a few diagrams to illustrate this stationary object. If the two forces that are external in opposite directions are of the same size, they will cancel each other out. The overall resultant force will not cause a change, so the box or the object will stay stationary. If a van is moving to the right with a speed of 12 meters per second at a constant speed, and there's a driving force or a force to the right of 400 newtons, and the same force acting in the other direction, the same size of force, they would again balance out so that the object remains at a constant velocity because the resultant force is 0. The second set of points in what you're expected to remember and recall is looking at Newton's second law, and from that looking at the idea of weight and mass. So if we see here now, Newton's second law, is it stated clearly? It may not be clearly stated here, perhaps, unless you are happy in using the equation to state that. You might want to amend or make your own sheet that clearly states it if you find that something you were struggling with. So here, the equation, can we use it? I hope so. We can check the mass and acceleration. They've given two diagrams now with different forces. So that means something you can do is look at these and remember that these forces are opposite directions. So you take one away from the other to leave the largest value acting in the correct direction. The third set of points in this is the idea of weight and mass. And we can see down here, it's important to understand the difference between weight and mass, because that could come up. It could be a question asking you the difference or to demonstrate your understanding. They've also put the equation and they've put the value of Earth's gravitational field strength, just so that you can see that number a number of times to help in your preparation. What we have is a large side of this sheet is dedicated to terminal speed. And does it necessarily go through the investigation, or does it go through an example of a skydiver? You might want to think, how would this be different to you investigating in class? So what we'd see is they have clearly outlined the stages of a skydiver reaching terminal speed and opening a parachute and reaching a new terminal speed. So hopefully in your preparation, these terms are familiar already. And it's just a case of identifying the steps. And remember, nice extended questions. This type of content is quite easy and straightforward to learn, so it might help you in the exam. So understanding how objects reach terminal speed, the forces acting on them are quite crucial. So if I go back and think about what type of questions are awarded a lot more marks this year, we've seen that Newton's laws rank quite highly. Foundation tier of the physics is ranked first. Newton's laws is ranked first on the higher tier of the physics. It's ranked third on the foundation tier, including the practical work, and it's ranked second. So this is the type of content you might want to be focusing on. Work on energy, on the other hand, there's a lot of content there, and it's ranked first for double award physics this year. It's ranked fourth on the foundation tier, but it does require some of the practical work. And it's ranked first or joint first for higher tier physics, and it's also ranked joint first for foundation tier physics. So now we might want to quickly look through these topics just to see how can they condense so much into a single page. You might find 2 pages more appropriate. So work and energy has a lot of content. It starts with this idea that when a force acts on an object, carrying on from Newton's laws, energy is transferred, but the total amount of energy remains constant because there's a conservation of energy. From that, you can see that they define work as this force multiplied by distance, but the distance moved in the direction of the force, not just any distance. Work is a measure of energy transferred. So those 3 are linked quite closely. Once you understand these fundamental things such as work and energy, we can then start to explore different types of energy, such as motion, which we might often term kinetic energy, or positional energy due to gravitational potential being above the surface of the Earth, or even energy that results in deformation of an object, also known as elastic energy. And we can see a single point here is dedicated to higher tier. So that equation for kinetic energy, being able to use it, rearrange it in order to calculate the elements of that equation. The equation for the change in potential energy. Rearranging is an important skill, and able to input numbers correctly. So a very important one to look at for some of you. Further down the sheet, what we see is points F and G focuses on the relationship of forces acting on a spring. So think of a spring as anything that can stretch or compress. And from that, again, there's another element for higher tier, which is understanding that the work done to stretch a spring can be found again, this time by the area again. Notice these themes for higher tier. The area under the graph often represents something, and in this case, a force extension graph will allow you to calculate the area under, which would be equal to the work done. And the final 2 points again, notice in the first few units, they look at real-life applications. These ones do again look at vehicles, so energy efficiency in vehicles, so concepts such as air resistance, rolling resistance, idling losses, and also the principles of the forces and motions on safety features of cars, such as airbags and crumple zones. So this very long list, WJEC have attempted to condense into a sheet. You might find that it is useful or doesn't have the information for you. So what I've done today is I've taken the time just to put those sheets in for you. I've gone through each one and put the sheets for each syllabus, so it might be useful. And at the last 10 slides, which you're not going to see today, I have put other sheets made by other teachers that I know that they find useful for their classes. I've put them in so you can have a look at different styles. Some have just information, some have information with questions. You might find that mixture works for you. So I hope you found today's session useful. Next week's session, we will start to look at the QER questions, the questions with extended reasoning. The final 2 weeks, I will hope to go through a full past paper for the higher tier and foundation tier, focusing on those top topics I looked at today. And I hope to see you again next week.